It's almost impossible, isn't it, to truly wrap your head around the sheer force nature can unleash.
It really is.
But picture this, 1815, you've got this volcano, Tambora, way over in Indonesia, Sumbawa,
Mm-hmm.
and it just explodes. I mean, with a power greater than anything we've ever recorded.
Unbelievable power.
And the immediate devastation,
Mm-hmm.
just awful for the people right there. Tens of thousands died, horrific stuff, ash falls, pyroclastic flows.
Yeah, it really puts our own existence into perspective, doesn't it? These,
Yeah.
fundamental geological forces at play.
Totally.
And while the tragedy in Indonesia was, well, enormous, what's truly fascinating, and maybe a bit unsettling too,
Yeah.
is how this single event sent these, shock waves across the entire planet,
Right.
leading to something we now call the year without a summer. That was 1816.
Exactly. And that's what we're diving into for you today. We've got this incredible resource here, a really detailed article from the University of Bern's Geographical Institute.
Oh, next.
Yeah, and it really unpacks both the science behind this whole thing and, crucially, the widespread societal fallout.
Okay.
And it's not just a bunch of dry facts, you know. This article, it has firsthand historical accounts, maps showing where all the ash went,
Wow.
diagrams explaining how it messed with the atmosphere, even pictures of artifacts and places connected to Tambora, so you get a really complete picture.
That sounds fantastic.
Yeah.
What makes a source like that so valuable is the way it connects all the dots, right?
Exactly.
It doesn't just say volcano erupted. It meticulously traces that chain reaction,
Mm-hmm.
linking this tropical event to the very real hardships people felt thousands of miles away, like in Europe.
Mm.
It just highlights the interconnectedness of our planet in such a striking way.
So our mission today is basically to pull out the most crucial insights from this deep dive into Tambora and that year without a summer.
Had it.
We want to show you how a volcano on the other side of the world could plunge Europe into misery and, maybe surprisingly, even spark some cultural shifts.
Let's do it.
Okay, so after Tambora blew its top, what exactly happened up there in the atmosphere?
Well, what's fascinating to think about is what went beyond just the immediate ash cloud.
Right.
The truly global impact came from this staggering amount of sulfur dioxide, SO2,
Sulfur dioxide. Okay. How much are we talking?
an estimated 60 to 80 megatons
Yeah.
just injected straight into the stratosphere.
Whoa, megatons.
Yeah. And to really grasp the significance for you, that massive injection wasn't just a local problem. It was the key trigger for a global climate shift.
Okay.
We're talking 3 to 4 times the amount Mount Pinatubo released in 1991.
Pinatubo, and that was the biggest eruption of the 20th century.
Exactly. So Tambora was on a whole different scale.
Wow, that's just a mind-boggling amount. So this sulfur dioxide, it didn't just, hang around over Indonesia, did it?
No, not at all. Once it got up into the stratosphere, that's that layer way up high, maybe 10 to 50 kilometers above us.
Right.
These sulfur gases spread incredibly quickly across the tropics. Think of these strong, consistent high-altitude winds.
Right.
We call them zonal winds. They circle the Earth at certain latitudes.
Like jet streams, sort of.
Kind of, yeah, but much higher up. These winds carried the gases around the globe in just a few weeks.
A few weeks. That's fast.
Really fast. Then, through oxidation, just a basic chemical reaction, the SO2 transformed into sulfuric acid.
Sulfuric acid up there.
Yeah, which then condensed into these incredibly tiny droplets. We call them sulfate aerosols.
Aerosols. Like in a spray can.
Similar idea in that they're tiny particles suspended in a gas, but these are natural and microscopically small. Imagine just a really, really fine mist of these sulfuric acid particles way, way up in the atmosphere.
Okay, so we've got this invisible veil almost of these tiny sulfate aerosols forming way up high. What do they actually do?
Well, these aerosols acted like a giant global sunscreen.
A sunscreen.
Exactly.
Yeah.
They were incredibly effective at reflecting incoming solar radiation sunlight back out into space,
Okay.
essentially dimming the sunlight that actually reached the Earth's surface.
So less sun getting through.
Precisely. And this reduction in solar radiation was the main reason for the global cooling that followed. And while those zonal winds spread the aerosols rapidly around the equator, their movement towards the north and south poles was much slower. Took maybe a year or two.
Okay, so a delayed reaction for higher latitudes.
Yeah, which meant both hemispheres felt the effects, but perhaps at slightly different times and, with varying intensity.
And here's where it gets really interesting. Because Europe, thousands of miles away, experienced this completely bizarre summer in 1816. Can you paint a picture for us? What was it like?
Oh, the historical accounts really do paint a grim picture.
Yeah.
I mean, the summer of 1816 in Central Europe was exceptionally cold
Cold. Oh,
and incredibly rainy.
yeah.
Just constant rain. There are even reports of persistent rainfall and, get this, snow in early summer.
Snow in summer.
Yeah, highly unusual. You look at detailed diaries from that time, and you see farmers just desperately trying to cope with these constant wet conditions. It was devastating for their crops.
I can only imagine.
And what's interesting is that the afternoon temperatures saw a much bigger drop compared to the mornings.
Huh. Why is that?
Well, it's likely because the increased cloud cover from all the moisture and atmospheric changes blocked the sun's warming effect during the day.
Makes sense. Less daytime heating.
Exactly. In Geneva, for example, the source mentions the maximum summer temperature decrease was almost 4 degrees Celsius. It's a huge drop for a seasonal average.
4 degrees. So, yeah, definitely not ideal weather for a picnic.
This wasn't just a bit of a chill, right? This had some really serious consequences, especially for farming.
Absolutely. Serious is an understatement. The
Yeah.
cold and the nonstop rain led to widespread crop failures right across Europe.
Oh, man.
Hay crops rotted in the fields before they could be harvested. The outlook for the vital grain harvests, wheat, rye, barley, it was disastrous.
Which would mean food shortages.
Exactly. And this, in turn, triggered huge price increases for essential grains, like wheat.
Prices went up. How much? Well, in Switzerland, for instance, the article states average annual prices in many markets doubled or even quadrupled between 1815 and 1817.
Quadrupled.
Yeah, and you have to remember, back then, most people were spending the vast majority of their income just on food.
Right.
So these price hikes meant that many families simply couldn't afford to eat. It led directly to famine.
Wow. That sounds like it would have just caused incredible hardship.
Hmm.
And probably a lot of social unrest, too.
Precisely.
Yeah.
The article makes that connection very clear. We also learned from it that the failed harvests fueled widespread fears of revolution.
People were scared.
And desperate. The number of people begging for food just exploded. The gap between the wealthy and the poor widened dramatically. Prisons became overcrowded.
And disease.
Yes, diseases linked to malnutrition started to spread. Things like typhus often spread in unsanitary, crowded conditions, and pellagra, which is a deficiency disease.
Awful.
In Switzerland, the source points out, the regions on the northern side of the Alps were particularly devastated by famine. Just constant cool, damp air ruining everything.
Did it affect everywhere equally?
No, interestingly. The source suggests that the more rural and maybe less connected regions sometimes fared a bit better than the seemingly more advanced areas with markets.
Huh. That's counterintuitive.
It is a bit. It shows how complex these things are.
It's sobering, isn't it, to think about how the impact varied so much and how the way society was structured really determined who suffered the most.
Absolutely.
The article even points out how different regions in Switzerland responded differently to the crisis, didn't it? Like some stepped in to regulate markets earlier than others.
Yes, that's a really important point. The information in the article highlights. It shows that famine isn't just a natural disaster. Political and economic factors are always deeply intertwined.
Right. Human decisions matter.
Definitely. The different responses in Switzerland really illustrate how governance and access to resources played a critical role in how well different communities could handle the crisis.
So some did better than others.
Yeah, and some areas were criticized, apparently, for not acting quickly enough, even holding on to financial reserves while their people were literally starving.
Oof. Tough decisions, but also.
Yeah.
So, beyond the immediate suffering, it's really remarkable how this year without a summer just embedded itself in the cultural memory. The article touches on some fascinating examples. Right?
Indeed. It's quite amazing. The unusual gloomy weather conditions, they're famously said to have inspired Mary Shelley.
Frankenstein.
Exactly.
Yeah.
She started writing Frankenstein during a dreary summer spent near Lake Geneva with Lord Byron and Percy Bysshe Shelley.
Stuck indoors because of the terrible weather?
Pretty much.
Yeah.
And Byron himself wrote that poem, Darkness, which paints this incredibly bleak picture of a world plunged into twilight.
Wow.
These artistic creations, they really reflect the anxieties and this feeling that the world was somehow out of balance during that strange year.
Art reflecting the times.
It's fascinating how such a drastic environmental event didn't just cause hardship, but actually became a powerful catalyst for creative expression, reflecting that widespread unease.
And it wasn't just in, famous literature, was it? The article mentioned other ways people remembered this extraordinary period.
Absolutely. The source talks about a sort of culture of remembrance that emerged especially in Central Europe.
Culture of remembrance. How so?
Well, there were numerous written accounts, obviously, but also illustrations, even satirical prints.
Satire. About a famine.
Yeah, sometimes mocking profiteers or the situation. They even created these things called inflation medals. Turing's medallion, literally medals marking the incredibly high prices.
Medals for inflation. That's wild.
Isn't it? And there were memorial prints depicting the hardships.
Yeah.
And, yeah, sometimes blaming those seen as profiting from the misery.
Ah.
And then when things finally got better, the return of the first proper harvest wagon in 1817 became this really popular image. It was celebrated in many places.
A symbol of hope, I guess.
Exactly. And the article notes that some of those celebrations have even evolved into festivals people still have today.
It's almost like people needed to find ways to process and make sense of something so completely unprecedented.
I think that's right. It was beyond normal experience.
Now, shifting gears a bit, the article also discusses the long-term scientific impact of Tambora. How did this event shape our understanding of the planet?
Well, Tambora became a really crucial case study. Although, interestingly, it wasn't fully understood right away.
Not right away.
No, it wasn't really until the eruption of Krakatoa in 1883 that scientists started a more systematic study of these kinds of atmospheric effects from volcanoes.
Ah, okay. Decades later.
Yeah. But the year without a summer was retrospectively linked back to Tambora in 1913.
Finally made the connection.
Right. And since then, Tambora has been revisited by scientists across loads of different fields.
Like what?
Well, it's been used to test theories about ice ages, to understand historical climate patterns, to assess the potential impacts of asteroid strikes.
Wow, asteroid strikes too.
Yeah, as a kind of analog for atmospheric dust. And even more recently, in discussions about geoengineering.
Geoengineering, like deliberately tinkering with the climate.
Basically, yeah. Deliberate, large-scale interventions. Tambora serves as this real-world experiment of nature that shows what happens when you put huge amounts of aerosols into the stratosphere. We can still learn from it.
So this single massive eruption 2 centuries ago is still giving us valuable insights into how our Earth system works? That's pretty incredible.
It truly is. The source really underscores that understanding Tambora highlights the profound interconnectedness of, well, everything on Earth.
Yeah.
An event in Indonesia had these cascading effects at atmosphere, oceans, ultimately human societies thousands of miles away.
It really drives that home.
And it also shows how vulnerable societies can be to sudden climate shocks.
Yeah.
Especially, when those shocks hit on top of existing political or economic stresses.
Themes that feel incredibly relevant right now, unfortunately.
They absolutely remain relevant in our world today.
Absolutely. So, as we wrap up this deep dive into Tambora and the year without a summer, here's maybe a final thought for you, the listener, to really consider. Given all our current scientific knowledge, all the incredible technology we have today, if an eruption on the scale of Tambora were to happen again, right now,
Okay.
what aspects of its impact do you think we would genuinely be able to manage effectively, really handle?
That's a big question.
It is. And what profound challenges, maybe unseen cascading effects, might still take our globally interconnected world totally by surprise? Would the resilience of our modern systems, our supply chains, our communication, everything, would it really hold up against such a powerful natural event?
It's definitely something to ponder long after this deep dive is over. How fragile are we, really?
Exactly. Something to think about.